Hello friends, in the previous video we created a key store using Java default provider on server machine. In this video we will create the SSL socket for the server machine using the Java default provider. Remember, we are working now on the server machine. We will create this in two ways. The first way is that we use an IDE on our server if that is possible. Otherwise, if we don't have an IDE on the server, we could use it on a terminal. And I will show you both ways how you can do this in using an IDE or using a terminal. So let's dive in. Now I'm using a Ubuntu server 18.04 and JDK 8. Now this is the entire code to create the SSL socket on the server machine. The majority of it is almost same as the creating a client side SSL socket, except for a few changes, and I will show you and highlight these changes so you can implement them. Now the first difference is that you might notice is that in this class on the server machine we will use the main method. The class should have a main method so that the server, when it starts, it will use this main method. After that we will create an SSL context using the SSL context class, and we will get an instance of it using the protocol that is TLS v1.2, the encryption protocol, which is TLS v1.2. Now here there is some difference than the client side creating the SSL sockets. Here we will need to create a key store. And to create the key store, we will use this class, the key store class, and which I highly recommend that you go through it because it has a good insight of information about the key store. Now we will call an instance of this key store class, and we call this method get instance, and we will use the type of the key store, which is JKS, Java key store class. Since we are using a Java provider, then we have to use a Java key store type. Now the type, you can find it in here. These are the types, the key store types of the Java default. One of them is the JKS, and these are the other types. Now remember, since we are using the Java default provider, then the type of this key store will be PKCS12. The other thing is that since we are using a Java default provider, then we can use JDK 8, 9, 10 or 11, unlike when we use the bouncy castle, when we have to use the JDK 8. The next step is that we need to load the key store. The first step is that you need to initialize the key store. The second step, the next step, is that you need to load the key store. You load it from the file of the key store. You remember in the previous video we created a file by the name of the SM key store, and we place it on the home directory. And remember, this was the file that we have created in the previous video. So this, we will use it and we will write down the entire location of it. The other parameter is that we need to give a password. You remember, again, when we use the Java security default to create a key store, we need to do one thing, is that the key store, and we need to give it a password. That's it, without any other parameters, like when we created the key store using the bouncy castle. With the bouncy castle we have used other parameters to initialize and give the characteristics of the key store. With the Java default security, we just need the key store and the password of it. And the password is extremely easy. You just pick whatever password and you convert it into character array, and you will get a character array, and then you can use it in here. The next step is that we need to create and initialize the key manager factory. We use the class of the key manager factory, get instance, and we use the algorithm. Now the algorithm, the key managers, here key manager factory, it is pkix, and it's of type X509, since our certificates and keys are of type X509. Now Remember, we don't add any provider, custom provider, because you are using the Java default provider. So we will get an instance of the key manager factory, and we need to initialize it. To initialize it, you need just the key store that we have just created, the key store instance, and the password of it, of the key store. Once you have initialized the key manager factory, then you can call this method to get key managers, which will give you the key managers where you can save in it the key material, which is the encryption keys. Likewise, when we do with the trust managers factory, we call the class of trust managers factory get instance, and we call the same algorithm, because the trust manager also uses the same algorithm, the pkicks, and we will get an instance of the trust manager factory. And to initialize it, we just need the key store. With the trust manager, we don't need a password of the key store, we just need the key store instance. And then we call this initialized trust manager factory and call this get trust manager to get an instance of the trust managers, which will save to us one type of certificate material, that are the certificates. And this way we have got two things. We got the key managers, we got the trust managers, which are the first and second argument to initialize the SSL context. The third argument is the secure random. It's pretty easy to get it. We just use the secure random class of the Java security. We get an instance of it, we give it some strength. We could do it only once, or we could do it twice using a seed. Now if we want to use the seed, we just need to give the length of the random number. We're using next byte, we use the length, and then we get a seed from it and use this seed as an argument for the secure random, and this way we will get a more robust secure random instance that we can use it as the third argument to initialize the SSL context. The next step is that we need to get the SSL server socket factory using the SSL context, that instance that we have just got, and calling the get server socket factory, which will give us an instance of the SSL server socket factory. This instance, we will use it to get an SSL server socket, calling create server socket. Here we have some difference than the client SSL. When we create the client SSL socket, here we need to add three parameters. The parameters are the port of the server, the log bag, and the local address or the IP address of the server. The port, it's the port of your server. In my case, I'm using Postgres. Postgres have only one port, which is 5432. In your case, you should write what is the port of your server. The log bag usually a positive number more than one, which represent the allowed connections at one time, and then the inet address .get by name, which will give you the IP address of your server. So here you need to add your the IP address of your server. Now once you have done these three parameters, three arguments, don't forget to cast to an SSL server socket. Otherwise you will get a server socket, a regular server socket, not an SSL server socket. So don't fall in this mistake. You have to cast it to an SSL server socket so you can get an instance of the SSL server socket. Next step is that we need to query what cipher suits available in our server. The cipher suit, as we have mentioned before, is just a combination of cryptographic algorithms. And the way to get that is that we call the socket, the server socket, get supported cipher suit will give us a list of these cipher suit. Then we assign them to the SSL server socket, calling set enabled cipher suit. Next, we need to assign the parameters to this SSL server socket in the same fashion that we have done with the client SSL socket. The cipher suit, the protocol, the encryption protocol, and endpoint identification algorithms, which we said as we will use it when we do the handshake, so that the connection can be made. Now, one thing to advise you, this when we use the Java security default, the suits, the cipher suits, are a little bit different than the bouncy castle suits. In the client SSL socket, we use the bouncy castle cipher suits. Here we are using Java security, Java default cipher suits. There might be differences in between these two suits. So my advice is this: if you are, either you use Java security for both the client side and the server side, or you use bouncy castle as a provider for both the client side and the server side. Don't mix between make the client as a bouncy castle and make the server as Java security, because these cipher suits probably are different, and it will make connection errors when the server connect to the client. This is a possibility. So, but in any way, you can find these cipher suits of the Java default security in this link. Actually, it's in this link here, where you could see all the Java security default cipher suits, which are these ones. So my advice to you, if you're going with the Java security default, then use it as your provider for both sides, to create the SSL socket and the key store for both sides, for the server and for the client. Or you use the bouncy castle all alone to create the SSL socket and the key store for both the client and the server. In this case, you will avoid any errors due to the cipher suits differences probably, or any misconnection that could happen due to misunderstanding or misconfiguration of this cipher suits. The other thing is that set want client auth or set need client auth. Now you see here this one, set need client auth to true. Remember when we set that when there is a client want to connect to the server, and the bidirectional authentication, the client authenticate the server and the server authenticate the client. Now if we set this set need client auth to true, in this case the server will request a certificate from the client certificate. The server will request, and the client must provide a certificate. If the client doesn't provide a certificate, then the connection will be refused. The server will refuse that this client connect to the server. So this is if we set need client auth to true. The server will require a certificate from the client, and the client has to provide a certificate. Otherwise, the connection will be rejected. Now, again, my advice to you is that you don't go all the time with this method. There is another method, which is this one. Set want client auth true. Now the difference here, in this case, the client is mandatory to provide a certificate to the server. Otherwise, the connection will be refused. Here, the server will request, because not all programs over the internet, their client have certificates. So here in this class, the server will request whenever there is possible, whenever the client possibly have a certificate, then it will present it to the server. Otherwise, it will not present. But in either way, the client can connect to the server. So it's preferred to use this one, set want client auth to true. The final thing is that we need to assign these properties to the SSL server socket using the set SSL parameters. Here there is another difference between the client and the server. The client needs only one socket because it's just one connection. Now on the other hand, for the server there are many clients who want to connect to the server at the same time. So the server needs multiple sockets, so it can handle all these connections coming from the clients. Now we know that each socket is handled and run by a thread, which means that we need a multi-threaded server to handle multiple sockets. Each socket will take care of one request of connection from a client. So we have to get a multi-threaded sockets on a multi-threaded server. And the way to do that is that we create a thread factory first using the executor class, get default thread factory, which will give us an instance of thread factory which will create for us threads. Then this class, again the executors, we call a thread pool. Now there are multiple types of thread pool. My preferred one is new cached thread pool, which takes an argument of a thread pool. Now why I prefer this, in your case probably you will prefer another one, because in this case, suppose that you have 10 sockets, 10 clients, and 10 threads. Each thread handle one socket. If a new customer or new client, say number 11, comes, then this thread factory will create a new thread to handle a new socket, a thread number 11, to handle the new connection. Another way is that if you have 10 threads and 10 sockets, and one of the socket disconnected, the client leave his session, that means we will have now a thread empty, a thread is free. So if a new client comes, then this free thread will handle the new client. No need to create a new thread. So that's why I'm preferring this one, but it's totally up to you to use whichever thread pool type. Now once you have got the thread pool instance, what you need now is to create a loop file, a while loop, so you can create multiple acceptance of threads, multiple sockets. Each new request from a client, we will create a socket for it by using the .accept method, which gives us an SSL socket for each request of a connection to the server from a client. So the SSL server socket .accept will accept any request for connection to the server. We need to cast it to an SSL socket so we can get an SSL socket for that request of connection. And then we will use this thread pool to give a thread for this new request of connection to handle this socket. And since the execute method is of type it's a lambda expression, it's a runnable interface, so it's a lambda expression, then we could use the lambda expression in here directly, which will enhance the performance. And here it will comes the way how you will handle the exchange of data between the server and the client. Now this part is out of the scope of our course, so it's totally up to you how you wish to handle the exchange of the data between the client and the server, in which way. But in general, usually we will create an object stream and input stream for the server, for the coming input stream to the server from the client, and for the going out stream from the server to the client. And here you don't have to forget one important thing. Now since this data that coming back and forth between the client and the server going over the internet, then you must implement serializable interface. you must have to serialize the data that's coming back and forth between the client and the server. Don't forget this. This is a very important point. Now, once we have reached to this stage, and actually when we have reached to this stage, we already have created the, our server, SSL server socket, and the objective of our video here have been completed. Now let's try this class and see will it work, and if it works, will it give us an SSL server socket? So let's run it. And here, as you could see, the SSL server socket, which means we have got our server. Remember, I'm working on the server machine, so now I'm getting an SSL server socket with this IP address and with this port. And also I've got the thread pool. Now obviously the thread pool size is 0 because there is no client connected to it, so that's the pool is 0, but the pool have been created and waiting any connection from any request from any client. Now let's talk on how to create all these things using a terminal. How to do all these steps but on a terminal. And the way to do that is pretty easy. First of all, we need to create a directory, a general directory where we keep all the key store and things using this command. You can give the directory whichever name you wish, any name suitable for you, but remember one important thing: don't put this directory on your system files, especially on your JDK files. So never put it on, because it will not be accessible. This directory will not be accessible if you put it on your system file or on especially on the JDK files. So you need to put it anywhere else, suppose on the home, on the documents, on the downloads, wherever except the system files directory. For instance, I put this, I believe in here on home directory, I placed it. So place it in a place like at home or documents or downloads. Just don't put it on the system file directory, because it will not be accessible. Once you have done that, you change the directory to this directory and then create another directory by any name you wish. That directory will hold all the data. So in here you will hold all the data. So which data we will put in this directory? The data is this classes. Whichever classes you are using, whichever class, one class or two or three or more, all these classes you have to place in this data directory, and especially the main class, the main method class, this one, because from this one the whole program will start. And the way to do that is that you find where are these classes, where is the location. So in my case, I'm using sorry, it should be in this directory. So you go to this directory, for instance, in your case, where is this directory of all these classes? You typed it in here, which for each and every class. You have to do this for each and every class. You have to copy it, sudo copy, and get the directory of that class and the destination directory, which is this directory, and do it for each and every class. So move them all to this directory. Once you have moved all these classes to this directory, then you can compile them, all of them, by sudo java start.java, javac start.java. In this way, these classes will be compiled Once it's compiled, then you can call the main class, which is, in our case, it is this class. This is the main class. And then you could call it sudo Java, of course, and the server SSL socket, which is the main class Java, and the program will run. So this is the way if you wish to do it through the terminal. Pretty easy. Create one directory, anywhere put it except for the system file. Create another directory. In this directory you will place all these classes that you have created, 1, 2, 3 or 4 or what, how many classes you have created. Put them all, move them from the directory where they are in to the directory of the data, compile them, and then run the main class normally with using the Java command. That's it. That's the way how you could use the terminal instead of the IDE on your server machine. Now remember one thing, the key store type that we have created is of type PKCS12. Now in the next video we will create the key store and the SSL socket for the server machine using the custom provider that is the Bouncy Castle provider. Thank you very much.